So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you know, that this is an online platform for civil structural engineers to interact with us and ask their queries or doubts that they may have related to any RCC or steel design concept or any construction site issues or any project that they are doing. So, this is the 60-second such episode that we are conducting. And let us take the questions for this week. So I'll share my screen and we will start taking the queries that have been asked. So let me share my screen. Yeah, just give me a minute. So the first question for this week has been asked by Engineer Manish Kumar Pandey. He's from Ranchi and he's a working professional. And in the same context, another question has been asked. So I'll combine both the questions together. So this question has been asked by Engineer Kirti Gupta. She is from Noida and she is a working professional. So I'll take both the questions together because they are of similar nature. So the first question being asked over here is in dual system clause the base shear must be distributed 25% to columns and 75% of wall. If it is not fulfilling, how to take care of this clause? No, so what do you mean by not fulfilling? Have you found out how much percentage is your walls taking and uh, how much percentage are your columns taking? And it is not only base shear, it is the effects of EQ loads. So you need to first find that out. Let's say if your columns are taking lesser, maybe they are taking, let's say, 15% of base shear, suppose. So then you need to increase the column sizes, try to make them stiffer so that they start taking or start resisting greater shears. Or then you need to look at maybe reducing the wall sizes. Maybe the wall sizes that you have provided are too much, a lot more than what was required. So you may think of slightly reducing the wall sizes, or try to see what is the frame that you have created, what is the frame that you have developed. Frame, by frame I mean the lateral system, the beam system that is joining your columns to other elements. See how it has been made and whether any modifications, maybe slightly increasing their sizes, maybe it will transfer some of the base shear to columns. So try to do these things and then check whether it increases the percentage distributed to your columns or not. So first of all, try to make your columns stiffer, larger columns, maybe add more number of columns. Second thing you can do is try to maybe reduce the size of your walls, slightly maybe reduce than it was being provided. And uh, third thing you can do is try to just modify your beam system so that more forces flow to the columns. So try to do these things and then see what happens. In the same context, the next question was, in dual systems, we ensure the design of columns to be such that they resist 25% of base shear. Separate load combinations. Yeah. So you have made a jugaad type of load combination just to ensure that 25% of base shear is getting transferred to the columns. Where 2 is the factor introduced to make the base shear. Yeah. Yeah, to okay. So to answer Kirti's question, one more point I like to add over here. Suppose your columns are not taking, or they are not getting designed. They are only, as Mr. Manish is saying, they are, let's say, only getting 12.5 or 13% of the loads base shears, and you want to artificially, let's say, increase them and ensure that this 25% clause is met. One more reply that I would like to give is, so the first reply that I gave was more in the terms of behavioral aspects, but here, if your columns are not taking the full 25% designated loads and they are only taking lesser percentage, this is another point that you can do, and that is, let's say you had applied some EQ loads, and for EQ loads they are taking, let's say, 13% of your total base shear. Now what you do, you just have a small jugaad, and so for example, this was for your load combination 1.5 DL plus 1.5 EQ. So for this particular load combination, it was taking, let's say, 13%. So now you need to, because you just wanted to ensure the codal clause, what you can do is, you wanted 25% to be taken, it is taking 13%. Take this ratio, let's say it comes to around 2 point something. Okay, no, it will come to, let's say, 1.9 something. So now what you do, you make a load combination which is going to be like this, and the load combination factor, you multiply it artificially by this factor, which was nothing but this ratio, and you multiply your load combination by this factor. So now you have created a combination which you will use just to ensure that columns are designed for higher base shears. Okay, and in this manner, practically you can try to satisfy the 25% limit. So this is how you can design, because the columns have to be independent, the perimeter frame has to be independently designed to take the 25% base shear. So this is the way in which you can do the practical aspect of it. So the earlier response that I was trying to give you was more to do with the behavioral things, that how you can improve the behavior. But practically, if you just want to fulfill this 25% clause, you do it this way, that whatever your load combination you have made, you artificially multiply it by this sort of a multiplication factor, which will be nothing but like this, and then you see how much of base shears are being taken by columns. So for this load combination, you only design your columns, nothing else. Mr. Manish is asking, are the beams framing into such columns also be designed with above load combinations? Yeah. So the code says the perimeter frame. The code uses the term perimeter frame. So that includes the columns plus the beams. The part of your perimeter frame will include beams and columns both. So the entire perimeter frame should be designed for these artificially magnified load combinations. Is this clear? So this, for example, in your case, you had made this combination. So you use this combination for designing your columns as well as the perimeter beams. Okay. So this was both the queries related to similar uh, related to similar topic. Now we have a query from engineer Akash Babar. He is a working professional from Sangli, and he is asking, what are the design guidelines for grating and checkered plates? uh, I'm not aware of design guidelines, but basically you have to design them so that they are able to take the required loads. I'm sure there might be, I think there might be any specific IS code for it. However, I'm not aware of any such code right now. Design wise, whatever is the load you need to take on your checkered plate or grating, you design it as per your, let's say if it's a checkered plate, whatever supports you have provided. Generally, we treat checkered plates as two-way spanning slabs. So you may take the similar moment coefficients that have been given to you in IS 456 for two-way slabs, and from there, uh, on the basis of load to be resisted, you can find out the checkered plate thickness. For grating, generally it's sort of a grids beam, because there are grids, there are flats provided like this, bidirectional flats, and for gratings generally you get from the manufacturer side, you get the load sheet. By load sheet I mean they will tell you that for what span of your grating. Okay, and grating will generally be two-way spanning. You can have checkered plate one-way spanning, but gratings usually are provided as two-way spanning. That means you need support in both directions, for all four directions, let's say. So for gratings, generally you may get load data sheets provided by the supplier or manufacturer, where they will give you that for this span of grating, this is how much live load it can resist, and such sort of a thing. So you may refer to those guidelines, you may refer to those load sheets that are given by the manufacturer. Or if you want to do it on your own, you can make a quick model where you can make these types of line elements, give them the size of the flat, and have all these edges restrained on all four sides, have all these edges restrained, and then see the moments that you're getting in these individual flats, and then find out the size requirement for the flats. But are there any other specifications as per IS code? I am not sure. There might be some, but I also need to study. I don't know. So his second question is, are there any design guidelines or references for grade slabs at plinths in industrial floor? Yeah, there are a couple of good guidelines that are available. So uh, one is your British document, and that British document is uh, TR 34. No, yeah. One is this TR 34 document for industrial floors. It's a British document which you can refer, and it's quite detailed. And so TR stands for Technical Report number 34. Uh, this is a good document if you want to find more about the industrial flooring and its design. Then you also have another document which is your ACI 309, I think. ACI 30, no, ACI 360. ACI 360 is another document which you can refer to. Okay, so this is the American code, ACI 360. It's not AISC, ACI, American Concrete Institute 360. This is another document for understanding the guidelines for industrial floors. You also have an Indian document which has been published by the uh, Indian Concrete Institute, and that is called as the TC09. So this has been published by the Indian Concrete Institute. It takes most of the things from the TR 34, and this is also a good document if you want to study more about industrial floorings. The calculations are similar to what are given in the uh, what we do for rigid pavements based on Westergaard's equation. So those types of calculations remain the same. So you might be interested in going through these documents. Okay. Then the third part of his question was how to determine the maximum pore length of concrete and what is shrinkage strip. So shrinkage strip is basically when you want to leave a portion of, so this is, let's say, casting concrete, and this is also concrete. This is, I'm showing you the plan view. And suppose you wanted to, so instead of doing a continuous casting, maybe to have, maybe to release the temperature effects or shrinkage effects, or just because there were two dissimilar structural systems which you wanted to isolate from each other, separate from each other. Suppose you wanted to do that, then we leave this part, let's say, uncast, and this you will cast later. So such a strip or such panel or whatever, such portion which you are not casting uh, together and you are separately leaving this space empty to be cast later on, such a uh, element is called as a shrinkage strip. Generally you see in rafts, basements, where you have, let's say, a podium uh, area and a tower area, and you wanted to separate out the podium area from the tower area, then we generally leave these shrinkage strips, which we will cast later on. How to determine the maximum pore length? So maximum pore length will depend on your capability, how much concrete you are able to cast in a single operation. Second, it will depend on the temperature effects, if applicable, that beyond how much length temperature effects will become critical. So temperature effects or your ability to cast concrete in one single operation, or maximum pore length will also depend on maybe the structural configuration. So as I just said, that maybe if you wanted to separate out the tower area from the podium area, maybe you decide to only cast till this length and then leave a pore shrinkage strip, because then there was uh, a podium area which you did not want to cast. So that may also determine the pore length. So on these aspects you may decide your pore length, and this is what is shrinkage strip. So these were the queries by engineer Akash, and then we move on to engineer engineer Shaktivel from Chennai. He is a working professional, and he is asking, I am actually facing difficulty in connection design and how to interpret the stat results. No, I mean, what is the difficulty you are facing? You have to be more specific with your query. What is the difficulty you are facing? Stat will give you the, so you can take the member end results and then you note down these member results and you then use for your connection design. So you have to be more specific with your query, that what is the difficulty you are facing. By the way, we have done very good course on connection design and detailing. Connection design and detailing, we have done a very good course on it, where we use idea statica plus manual calculations, and we have taken a lot of different connections and uh, dealt them in great detail. So you may be interested to have a look at that course also, but be specific in your query that you are asking. His second query is in RCC structure, how to apply lift load, and should we model it as plates, and how to apply floor load surrounding lift area. Lift load generally is very negligible if you see, The see major lift load is your, so if this is the plan view of your RCC wall, let's say you have provided a RCC wall all around, your lift load generally is going to rest on the, so what happens is that they will have this type of a, in elevation, if I were to show you, this is their lift, and then they will have a top, okay, and then they will have a, now if it's a machine room lift, then there is a machine room over here. So this machine room load is to be considered on this top slab wherever you are going to place your machine room, and generally your lift goes till this level. This is, let's say, the topmost floor level where the lift goes. Above that there will be machine room. Now that machine room will have some motor, so that motor load has to be considered, and it has a pulley system, so that pulley basically helps your lift to go up and come down. So you will have to consider the loads of this pulley. Those loads are generally given by the equipment supplier. So you have to do this. In machine room less lifts that you get these days, you will not have any separate machine room, but the motor is connected to the lift itself. So you will have your lift and it has a motor connected to it, and then there is a pulley over here which will do the lifting and all those things. So in such cases, again, you need to just apply the load that is given for this pulley, that is given by the equipment supplier. So here you may provide some beam, and you may apply those loads on this particular beam. So, and lift load are not much. Even if you see 1000 kg lift means what, 10 kilonewton load. You see, 1000 kg, if it is taking load of, let's say, 8 people or 12 people, it's a 1000 kg live load. Even if you consider 2 times impact load, that is only 2000 kg. If you were to add another 1000 kg for equipment, although it's not so heavy, but even if you were to add 1000 kg for equipments, we are looking at 3000 kg, that is only 30 kilonewton, which is nothing. You understand? So lift loads are very nominal if you compare with the overall structural capacities that your elements have. Good. So this was Shaktivel with the query. Now we have Engineer Shiva from Vizag, from Vishakhapatnam. He is asking how to apply rolling shutter load and weight motor on beams, how to consider loading on beams in case of garage weather. What is garage weather? I don't know. We should consider point load or UDL load. How to apply rolling shutter load? It's again, you, there is a, generally wherever you provide a rolling shutter, there is a frame that you provide, and from that frame, again there will be some motor element over here, and from that motor your rolling shutter, uh, let's say this is your rolling shutter. So generally that rolling shutter, it has rails. So on rails, the rails are fixed to this frame, but the motor is suspended usually from the top beam. And so you may have two motors, or you may have one central motor, whatever. So again, you need to ask from your rolling shutter supplier what are the loads, and then those loads you can apply it as point loads on these beams. Again, the rolling shutter load is not much, so it's it's a very small amount of load if you compare with the overall structural capacities that your elements have. Okay, next question is from Engineer Ketan Mahajan. He is from Jargaon and he is a working professional. So he had put one query last week which was related to a Proflex sheet warehouse, and it was I think I'll bring that image from the last session. Let me just try to bring that image from the last session, because these set of queries have been asked in response to the questions put in the last session. Let me see if I can get it. Yeah, I think this was the image that he had shared. Yeah, so this is the image that he had shared last week, and in the same, in continuation to this is a follow up he is putting. And what he is saying, where I have asked about the load application on steel beam. So this was his Proflex sheet, self-supporting roof resting on a steel beam. Instead of applying all the loads laterally, won't it be more appropriate to resolve the forces into two components? Yeah, of course you have to apply it as two components. So when you your Proflex sheet supply will give you two reactions. One will be like this, one will be like this. So one will be the gravity direction component, one will be the lateral component. So you have to apply both, obviously. Yes. Then his next query is also due to this lateral load on column edge. Huge movement is getting generated at steel and concrete column junction, resulting in more thickness of base plate. I have shared idea statica image. Where he has shared, let me check the email. I'll just check the email if he has shared on the email. So many people have this misconception. Many people have this misconception that your Proflex sheet thing is is cost efficient, but it's not so. It does not come out to be cost efficient, because you may save on your rafter system, because that Proflex sheet itself is going to take the loads. It's a self-supporting uh, structure, to so to say. But whatever you are saving in Proflex sheet, you put a lot of extra material in your columns, in your beams, in your footings. So finally, if you see, it's not a saving that you get. So this is his hollow section, and then this is the connection that he has designed. So he is saying that in this connection, he is getting, I'm getting base plate thickness of 40 mm, which is huge. Is there any way I can economize this connection? So instead of putting like this, what you do is you provide gussets. So if I were to show you plan view, let's say this is your column in green, steel column. So I'm showing you green column in plan view, hollow section, and this is your brown is the base plate. So my suggestion for a better structural system will be that you have gussets introduced like this, okay, and then you also have gussets like this. Continue them like this over here with small pieces, and then you make stiffeners also. Are you with me, Zoba? What I'm saying? You do this and then give a bolting arrangement like this. This will result into a much more stiffer connection, and this will help you to reduce the base plate thickness also. So instead of the connection type that you have given, try out a connection like this. In my opinion, it will be a better connection than what you have provided. Okay, then his next query was, is there any clause regarding the distance between concrete pedestal edge distance and base plate anchor diameter? I have read that some designers take it 6D, where tension is there in the anchors, so that the anchor does not pull out. Please throw some light on it. You may refer to, uh, try to refer to chapter 17 of ACI 318. They have given a detailed this is a detailed chapter on the anchors which connect your steel elements to concrete, and you will get a lot of good detailing rules that you can follow to avoid the shear failures or to avoid the bursting failures associated with these anchors. So you read chapter 17 of ACI 31825. His next query is, as there is no RCC beam, I am getting huge movements in footing, also resulting more footing size to manage the eccentricity. Is this correct, or any other way I can reduce the footing size? No, there's no other way. The As I told you, people have this misconception that Proflex sheeting is cheaper. It's not. This system will be almost as expensive as your, let's say, a truss system or a rafter system. So whatever you are saving over here, because the Proflex sheet suppliers will tell this to the client that, see, you are saving on truss, you are saving on rafter, etc., etc. But then lot of money you are putting into the designing these columns for huge movements. You will put a lot of money in these footings which will be very large because you are getting very large movements. So there is no easy solution. You will get large sizes for your movement, large sizes for your footing, because of the very configuration that you have provided. So no easy way out. One of the suggestions could be that, let's say this is your column and this is your Proflex. So this was your another column in elevation, and this was your Proflex sheet. Also remember that when your riser is very low, what happens, that it leads to a lot of thrust. Okay, when your riser is low, it leads to a lot of thrust. So if you could make a larger riser, your thrust should go down. Anyway, so what you could do is, if it's just a suggestion, if this was creating moments like this always, so this was the permanent direction of the moments on your columns. If you were to provide a footing like this on purpose, which is, sorry, on purpose, if you were to provide a footing eccentric in this direction. Okay, so what I have done, I have deliberately provided an eccentric footing in this direction. What it will do is that you had a permanent moment acting on your footing. Now this you are trying to balance out by what? This you are trying to balance out with the axial load P and its eccentricity E. So let's say you had moment M. You are trying to deliberately add eccentricity to the footing in such a manner that this almost comes out to be equal magnitude wise, so that net moment on this footing reduces. But why this will not be very helpful? The reason is that your axial loads will be pretty low. Your axial loads will be pretty low magnitude wise. So this system will also really not be very helpful. Another problem will be that if there is a net uplift in your column due to some wind action, then it will basically add to the entire eccentricity thing. So then this thing will not be workable. So another, maybe another strategy you could use would be, let's say, if I were to provide, see if you can provide piles over here, because piles will take good amount of tension, which will help you to reduce the sizes. So see if you can provide piles, or see if you can provide some stub columns. So maybe you provide a footing, sorry, maybe what you can do, these are just some suggestions which you can think of. So you provide a footing like this, then provide another footing, stub column footing, and try to connect these two elements together by a tie beam, stiff tie beam, so that the moment can be taken by both these footings in terms of compression tension. So you may try to think of such type of system also. So nothing much you can do with these Proflex sheeting things, because you are bound to get large footing sizes because of the uh, large amount of movements that you would get. Okay. His last question is, up to 3 meter level there is a brick wall, and above it there will be a sheet connected to column. So wind force up to 3 meter height will only act on the pipe size instead of taking whole tributary area between columns and above 3 meter. The wind will be more on the columns. Is this correct approach? I'm not clear with this question, what you're asking. You may do this, that if your brick wall is unconnected to your steel column, if your brick wall is independent of your steel column, you may not apply the wind loads for the first 3 meter height. So your argument could be that because the brick wall is unconnected to your steel column, you do not need wish to apply the wind load up to first 3 meters. That argument you can make, and that is a good argument, I would say. All right. Okay. So these were his queries. Then Mr. Ketan Mahajan has put another set of queries. So I'll just take them also. His next question is, for structural audit purpose, is there any reference in IS code where age of building is stated, where if this particular building is this much year old, then it can be dismantled, etc. Only CPWD manual states this, that for various types of buildings, the economic life shall be taken as below. No, I am not aware. There might be some IS code, but I am not aware of it. Maybe you need to search on the internet. But I have never seen in my life any RCC structure, RCC frame structure in good condition for more than 40-50 years also. 75 years is a long time. I'm yet to see a good RCC structure, frame structure I'm talking about, having a life more than 40-45 years. I don't know. I have never seen. If you people have seen, just inform me. I'm yet to see. Yeah, those RCC structures which are old, let's say those which were built in 1950s, 60s, 1970s, they continue to perform well. But any structure made after, let's say, 1980s, 1990s, I'm yet to see them in good condition. And looking from their condition, I don't think that they would survive for a 75 years life or even a 50 years life. Anyway, so these were the queries that were put in the put on the Google form, put in the Google form. Now we will take the questions from the live audience. So the first query is from Engineer Rishabh Thakre. He is asking, what if the column width and beam width is same? How is proper bar placement, as column cover is 40 mm and beam cover is 25 mm? and column are parallel to each other. How beam reinforcement shall be carried in columns? Yeah, so this is a problem that is often faced. That let's say in plan view, this is my column, and you had the same beam size, and your column reinforcement was like this with a 40 cover. So many times this problem happens on site, and it's not a very good practice. But what they do is that one of their beam bars lies outside the column bar, and they say that this is because that this is 25 this is 25 and because this was 40, the column bar is at a larger distance than your beam bar, and therefore many do this incorrect, inappropriate detailing where their beam bars will be outside the column core, so to say. This is not good. So in such cases, you may be forced to increase the cover so that you are able to ensure that your beam bars are inside the column core. Okay. Or sometimes people do this way also, that they will make a 1 in 6 slope, and in plan of course, and they will try to take their bars inside like this inside the column core. But yes, this is a practical problem that is faced, and for this, best solution is to have more side covers to your beam bars. There is no restriction on higher. Uh, there is no restriction on the cover which is higher side covers. If it is higher than your minimum criteria, there is no problem with that. Is it a good practice to provide slope to ensure beam bar in column? Yeah, I would say that. I don't see any problems with this. This slope is in the plan view, so yeah, I don't see any problem with this kind of a detailing. If you see in retaining in RCC structural walls, when we have boundary elements and when we have your web, generally we take the web transfers reinforcement inside the boundary element by providing such kind of a slope. So it can be done. Yes. Next query is from Sadashiva. In deep beams, how can we calculate the XU value, neutral axis value? What is the formula? So formulae for deep beams are sort of based on theoretical results or theoretical formulae. So generally in deep beams, because of the in-plane shear deformations, your neutral axis, you may not be able to do it as per the general principles where we assume plane section remains plane. So in deep beams, plane section does not remain plane, and therefore you may not be able to use the analytical process way in which we calculate the neutral axis depth. So therefore different codes gives you some different approximate formulae to calculate the neutral axis depth. So you need to refer to such codes or such documents to calculate neutral axis depth in deep beams. So why are you not able to use your general analysis procedures for calculating neutral axis depth? Because the plane section remain planes assumption is not valid for deep beams. Then next query is from let me see. Okay, next query is from engineer Vineet. He is asking procedure for procedure of casting deck slab when studs come welded on the beams. What do you mean by procedure? Procedure means when studs come welded on the beams. So you mean to say that because there will be studs that they're welded on the beams, how will you place your deck slab? Is that your question? So in such cases, you will have to make punch holes in your deck slab. You need to make punch holes in deck slab, and then you need to uh, insert that deck slab through your stud, and then the procedure remains the same. The other steps remain the same. His next question is, Mr. Vineet, how to design walking columns? No, walking column means planted columns or shifted columns. So, what do you mean how to design? The process of planted columns, you just do your analysis, find out the forces, provide the reinforcement. Walking columns generally mean planted columns or shifted columns in plan view. Okay. Yes. Is it a okay? So I think these were the queries that were put in the Google form, and we have also taken the queries that had been provided by the live audience. So is there any other query? Is there any other question? I'll just wait for a couple of minutes. Yes, please. Let me see on the Google form. We are waiting for any other question. Mr. Ketan Mayan is asking when is the course on machine foundation coming? Maybe we'll try to do in future. Maybe we'll try to do in the near future. I don't know as of now. As of now, we are doing the RCC design course using the American codes. That is the ACI 318 and the ASC 722. So, are there any other questions? No. I'll just check what else has been asked. So, there is this query by engineer Rajendra Kamre. Uh, let us take this. So, he has sent one PDF attachment. I'll just open that. So he is asking, he has shared this drawing, and his query is, so he has shared this drawing, and his question is to control punching shear, two-way shear. Is this system acceptable? What is the system? Okay, what they have done is that these, I think this is a raft because he has not mentioned it clearly, but I'm assuming this is a raft. These are the columns, and all the individual columns, they have provided this kind of a tie beam. So this seems to be a tie beam integrated with the raft itself. So to control punching, is it acceptable? So what has been basically done, that if your column had a two-way shear, you have deliberately, on purpose, instead of having that two-way shear, you have tried to make it a one-way shear case by adding a very stiff element over here. But then the problem with this system is that now this entire thing may punch. It's quite possible that this entire thing may have a two-way punching effect because they have just made two columns and tried to connect them with this sort of a tie beam. So it is possible to control punching through this arrangement, but then you just need to also check. Maybe what you can do is, on this perimeter, you may try to make a perimeter d by 2, and you do what, you just add up the column loads and see how much will be the approximate punching shear on this perimeter, and try to check whether this perimeter will satisfy for your raft depth, will it satisfy the punching or not. So this check you may have to do on your own, or you may be interested in finding out the stresses. You may be interested in finding out the stresses around this column. So you can go to Safe. Which software is good for this arrangement? You use Safe. Safe is a good software. So in Safe software, you can just check the stresses around this, shear stresses around this perimeter, and try and see if it is less than the permissible VC or not. Okay. All right. Then Mr. Rishabh Thakre is asking what to do if a structure is seen with settlement cracks and vertical cracks on beams. Repair it, wait and see the first, check or try to ascertain the cause for the cracks. If it is settlement, or uh, if it is due to settlement, I would suggest let the structure settle and then try to repair it. These days you get some uh, stretchable epoxy based, or I think some rubber based or whatever, I don't know the exact composition, those types of fillings which will also stretch with the crack width if it increases. So those types of repairing techniques you may be wanting to use. So it depends on where you are getting cracks, what is the nature of cracks, that you come up with a repair strategy. Okay, so I think this is all for this week then. We have answered all the queries that were put on the Google form. We have answered all the queries that were there on the live chat, and we have also taken the queries from email. So I guess this is all for this week then. As you know, once every week we meet when you can ask your queries and we try to take them up. But throughout the week, if you want to put your questions, the Google form link remains the same. So you can use the same Google form link to post your queries. And once every week when we meet, we will take it up. Or if you want to contact us, message us on WhatsApp. This is the link on which you can click and message us on WhatsApp. So I'll just put that also. So I have put both the links in the live comments. You can use this also. Okay. So that's all we have for this week then. See you next week with more queries. Till then, have a good time and have a great week ahead. Thank you very much for joining. Bye bye.